Hey guys, welcome to Thursday morning's video. We are going to do the other two parts of our notes on solving quadratic equations algebraically. Decided to go ahead and combine part 2 and part 3 into one day's lesson because I think you all can handle it, and otherwise it would be another short 5-minute lesson or whatever, and I don't want to do that. I want to actually give you a little bit more work this time. So anyway, the first thing that we need to do is we need to solve by factoring. The steps on doing this is getting one side equal to 0, straightforward. Write the polynomial in decreasing degree. That's pretty straightforward. Factoring, those of you that aren't good at factoring, guess what? You're going to get some more practice at it. Then you're going to set each factor equal to 0 and you're going to solve each equation. We're going to do a basic one first. Take a look at number 19. Number 19, it says x squared plus 7x plus 12 equals 0. Is one side equal to 0 already? Yeah, great. We're done that part. Write the polynomial in decreasing degree. Well, we have x squared, then we have x to the first, and then we don't have an x, so there's decreasing degree. It's already there. Factor it. Guys, this is a very straightforward factoring. Just a reminder. What multiplies to get you 12 and adds to get you 7. So I want to multiply to get 12, and I want to add to get 7. Well, that's easy. That's 4 and 3. Since my leading coefficient is 1, that is my shortcut. Everything's done. X plus 4 and x plus 3. Now it says set each factor to equal to 0. Well, x plus 4 is a factor and x plus 3 is a factor, so set them each equal to 0. X plus 4 equals 0. X plus 3 equals 0. And then solve. Well, how do I solve this? Subtract 4. X equals negative 4. Subtract 3. X equals negative 3. There you go. I know that one's a little simplified and a little bit easy, but I think that you guys can handle this. Number 20. What's missing? What's the very first step? Oh yeah, gotta get one side equal to 0. I don't have one side equal to 0. Guys, don't be silly. Don't move these two to the right-hand side. Move this negative 12 over here. How do I get rid of negative 12? Well, I add 12. If I add 12 to one side, I have to add 12 to the other. So this becomes x squared plus 8x plus 12. Now that equals 0. All right, it is in the correct order. So what do we have? We have to factor it now. X times something and x times something. Well, what multiplies to get 12 and adds to get 8? Well, 4 and 3 is 7. How about 6 and 2? Pretty straightforward, right guys? And then we just solve. X plus 6 equals 0. X plus 2 equals 0. X equals negative 6. X equals negative 2. Okay. Let's take a look next at, I don't know. What do I feel like? Number 22. 6x squared plus 3x equals 0. Well, is one side equal to 0? Yeah. Is the polynomial in decreasing degree? Yes. Well, what's the next thing I gotta do? Is I gotta factor it. Well, how do I factor this? This looks like it needs a GCF. So my greatest common factor between 6x squared and 3x is just simply what? 3x. So I pull out the 3x. 3x times what gives me 6x squared? Well, that's 2x. Plus, please do not forget this part, 3x times 1 gives me my 3x. So I have 3x times the quantity 2x plus 1 equals 0. And if you want to make sure that you did it right, this times this is 6x squared, this times this is 3x. Now, this says set each factor equal to 0. So 3x is the first factor, that equals 0. 2x plus 1 also equals 0. Well, if I divide this by 3, 0 divided by 3 is still 0. Then I have 2x plus 1 well, sorry, I'm just going to subtract 1. So 2x equals negative 1, divide by 2, and I get x equals negative 1 half. So my two answers are negative 1 half and 0. Okay. Number 23. This one's a little bit tougher, but again, go into your steps. Is one side equal to 0? Yes. Is the polynomial in decreasing degree? 2, 1, 0. Yes. Remember, the degree is the number that's above the exponent or is the exponent on the variable, guys. Now we got to factor this. Ooh, this one's a little bit tougher. How do I factor this? Remember, that using our product sum, we want something to multiply to get 6. How did I get 6? 2 times 3. And I want the sum to equal negative 7. So I need something that multiplies to get positive 6 and adds to get negative 7. Well, that tells me that I'm going to have two negative numbers here. So I think my two magic numbers are going to be negative 6 and negative 1. So what do I do with that? Well, I do 2x squared minus 6x minus 1x, because negative 6 and negative 1 add to negative 7, so I just rewrote those two, plus 3. Okay. Now I have 4 terms, so I'm going to put parentheses around each pair. What's the greatest common factor of 2x squared and negative 6x? Well, that's going to be 2x. So I'm going to pull the 2x out, and we have x minus 3 left. What is the greatest common factor between negative 1x and positive 3? Well, that's negative 1. So I'm going to take my negative 1 out, and that's going to give me x minus 3 again. The reason I wanted the negative pulled out here is because I want this factor and this factor to look exactly the same. If I hadn't pulled a negative 1 out, this would be a negative 1 here and a positive 3, and that wouldn't work for me. Since these two factors are the same, those two become 1. So I have x minus 3, and then my other factor is what's on the outside, 2x minus 1. And that still equals 0. Well, guys, we still have to finish the problem, okay? So what do? We have x minus 3 equals 0, and 2x minus 1 equals 0. Well, this is pretty straightforward. Add 3, you get x equals 3. And then you subtract or add 1 to both sides, you get 2x equals 1, divide by 2, and you get x equals 1 half. Okay. What you think? Thinking you're doing all right? I hope so. I don't think this is too awful bad. Let's take a look at number 24. I want to get one side equal to 0. So what am I going to do? I'm going to subtract 15x. Now remember, guys, like terms, okay? When I subtract my 15x, I'm going to go ahead and write it in order in decreasing degree. So my biggest is x squared. My biggest degree is x squared. Next is going to be my 15x. A lot of times I see students write my plus 36 and then put the minus 15x on the outside. That's why I put this step in here, writing the polynomial in decreasing degree. You want to do that because it makes life a lot easier. And why did I just write 13? Equals 0. Okay, so now what do I need to do? I need to factor this. Well, this is an easier factor because there's no leading coefficient here other than 1, so it's still x times x. Now, what multiplies to get 36 and adds to get negative 15? Well, they're both going to be negative, that's for sure, because a negative times a negative gives me a positive. And what do I got? Well, it looks to me like it's going to be 12 and 3, because 12 times 3 is 36, and negative 12 plus negative 3 is negative 15. All right, then I just have x minus 12 equals 0, x minus 3 equals 0, x equals 12, x equals 3. Gentlemen, ladies, what I'm really hoping that you're doing is the problems that I skip, like for example here I skipped number 21, and I'm going to skip 25, 26, 27 for this part. I'm hoping that you're going back and actually trying those on your own, just to see if you can get it done. Let's go on to the next page. What about something like number 28 where you have 9x squared minus 25 equals 0? Oh, wait a minute, this doesn't have 3 terms, does it? It only has 2 terms, and this goes back to what we learned on Tuesday, where we can just say, oh, let's solve for x squared by itself. So I now have, I'm going to add 25. So I have 9x squared equals 25. I'm going to divide by 9. I've got x squared equals 25 over 9. And then I take the square root, so I get x equals plus or minus the square root of 25 over the square root of 9, or x equals plus or minus 5 over 3. Don't forget what we learned on Tuesday. What do you notice? The ones that we have to solve by factoring, those have a degree of 2 and a degree of 1x. The ones that we had the other day don't have that degree of 1. All right, and then we have our friend quadratic formula. You guys know how to use the quadratic formula. You've seen it before. I know you saw it in Algebra 2. It helps if you memorize it. X is the opposite of b. A lot of people say negative b, but I always say the opposite of b, because if b is negative already, then the opposite is going to be positive. So this is the opposite of b, plus or minus the square root of the quantity b squared minus 4ac, all that divided by 2a. And b squared minus 4ac also has a specific, a special name. Okay. But we're going to get into that a little bit later. All right, so let's just pick a problem. This one, it's already set up in ABC form. This one's already in ABC form, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant. Let's take a look at this one. For this one, we want to make sure that it equals 0 for 1, and we also want it in ax squared plus bx plus c form. So we need to get rid of this minus 7x. So we're going to add 7x to both sides, and we're going to write it down in the right order. So we've got 3x squared plus 7x plus 3 equals 0. Now we have to identify our a, b, and c. A is equal to 3, b is equal to 7, and c is also equal to 3. And then all it comes down to is plugging it in. So I want the opposite of b. B is 7, so I want negative 7 plus or minus the square root of 7 squared minus 4 times 3 times 3 all over 2 times 3. And guys, always do the stuff underneath the radical first, okay? It's called a discriminant, and it can tell you lots of different things. But the main thing that you need to do is you need to make sure that you do this work first. So I'm going to work on that first. So I have the square root of 7 squared minus 4 times 3 times 3. So that's the square root of 49 minus 4 times 3 is 12 times another 3 is 36. Notice I'm doing all the math underneath first, and then I'm going to take the square root. So that gives me the square root of 49 minus 36, which is 13. Now, ladies and gentlemen, the square root of 13, we don't know that. So there's no more simplifying that. So all we can do is negative 7 plus or minus the square root of 13 over 2 times 3 is 6. And there's no other simplification that we can do. That's it. That's the list. No mas. Okay? Let's take a look at something like number 37. Okay, that's going to be the most complicated one. Remember, we want one side equal to 0. I usually like to make the right side equal to 0, so let's try and get rid of everything that's on the right-hand side and move it to the left-hand side. So I've got 5x over here, so I need to subtract 5x. Well, I have negative 4x over here, so I'm going to subtract 5 more x over here. So that gives me 8x squared. Negative 4 minus 5 more is negative 9x, plus 2 now equals negative 11. Well, hopefully you see that I can add 11 now. And I get 8x squared minus 9x plus 13 equals 0. And that's kind of what I want, right? So a equals 8, b equals negative 9, and c equals 13. Right, so we've got, let's go ahead and put it into the quadratic formula. X is going to equal the opposite of b. B is negative 9, so I want positive 9, plus or minus the square root of negative 9 squared minus 4 times 8 times 13. And all that's going to get divided by 2 times 8. And once again, guys, what's the first thing that I tell you to do? I tell you to do the discriminant, right? So the discriminant is the stuff underneath the radical, so let's go ahead and write that down. So I want the square root. Now I'm going to go ahead and do some of the math. Negative 9 squared. Please don't rely on your calculators here. Remember, a negative times negative is a positive, so negative 9 times negative 9 is 81. Minus. Now, I got 13 times 4 times 8. Well, 13 times 4 is 52, and then I'm going to do 52 times 8. That's 416, so I've got 81 minus 416. All right, well, what is 81 minus 416? Okay, that's going to give us a negative answer, isn't it? Yep. So I'm going to have I'm going to go ahead and do it up here. Minus 81, that's a 5. 41 minus 8 is 33, so I have negative 335. So I've got x equals 9 plus or minus the square root of negative 335 over 16. Well, we can take the square root of negative 335 if we can figure out if a number goes into that evenly, that we know a perfect square. The only perfect squares that could possibly go into this are multiples of 5. Okay, so does 25 go into 335 evenly? No. Let's see, we have 6, no. 7 squared, no. 8, 9. That's pretty much it. So it looks like we're going to have x equals 9 plus or minus I root 335 over 16. Looks weird, doesn't it? But it works. It'll always work for you. Alright guys, I think that's enough of this for today. Make sure you go back and work out some of these other problems for yourself so that you can do tomorrow's homework rather easily. Thanks, and I'll be back with you tomorrow.